Hello everyone, welcome back. My name is Rafael Escala. Thank you for watching this video. Today we will talking about the performance metrics. This is an important part of the same data intensive application book. This is the 2026 edition, okay? And this video I don't want to talking about only the concept. Actually, I want to talking about the part of practical that maybe you can use every day in your work. It will be very interesting and it will be useful for everybody actually. So okay, to start the video, I want to talking about that there are two metrics that is very important and have a strong relationship to the performance impact that you could have in your server, and that is the response time and the throughput, right? And the response time is the part that is the time that is actually is faced by the user. The user when he's launching an action in the website or an application, the time that it will take to receive a consequence of this action, that means the response time. Okay, is regular is the client side perspective, and the measure is usually taking the number of the seconds or milliseconds that takes an action in your in application. Okay, so that's it. Take a note of that. It's important, and the response time have multiple components to be that when you create a request, it will be a throwing of this sequence of steps, right? So I created a sequence here that maybe we can explain it in a moment, okay? So if there isn't a user, okay, that sending a request in that site, first, the first thing that the request it will be faced is the network latency. The network latency is that the travel of the request from the browser, in this case, if in a web application, right? The travel of this request from your browser at the infrastructure location that is located the server of this website. So the variables that it will be affected of the network latency, it could be the distance that it could have this infrastructure between the user browser, right? So the strategy that you maybe use to improve the network latency, if maybe create multiple data centers that or create another data center, or your infrastructure had to be on the strategic place geographically to be closer for multiple of your main user or customer, right? To improve the network latency, right? That's it. And the next step that the request will need to continue, okay, it will be the queuing delay. Queuing delay is in a step that usually is when there is a step that there is an overloaded of your system. Is the step that you have to take a note that when you are working on the server, there are a number of the limited number of the threads or that is dependent of the core, the number of the core that you have in your server, that it will be handled of yours of the server, right? It's like there is a number of the requests that it will um, process in parallel in this server, and if there isn't a new request that is not fit in this limited number of threads, it will be stored, or it will be in this queuing delay, right? And it will wait at the moment that it will release it an thread or process a queue that it will be the request finally be processed, right? So that is this intermediate step that or the step that is before of the service time. And finally, the service time or the process time is the core of your business. And finally, it will have the queuing buffer. This when there's the package of the response that we will finally send for the network latency, right? And the network latency in the end of this sequence is the travel of this response and to finally be received by the for the user, right? So that is the sequence of the step that response time it will be affected or it will be involved, right? That is a client response time. And actually, if you are trying, you are playing with the request that you are using in your application, that you will note that if any case in there will be a random response time, even if if the service time is the same, or maybe if um, the process of both of multiple requests is the same, because the difference of this random time it will affect it actually for example the garbage collection pauses, right? Because if there is a garbage collection process in that moment, because there are multiple sub process that is doing your server, it will be affected in the client response time. But actually, they are not. It's very difficult to control in your site, actually, like a software engineer. So you have to take a note that obviously not always it will be have the same response time or a static response time, right? So you have to only know that there are multiple reasons. If the TCP disconnection, you need to be retransmission, right, for that mechanical vibration on the rack server. So, okay, there are multiple reasons, right? That's all. And you have to note, okay, if your response time that you are working in this moment, how do you know that is have a good optimization or bad optimization? So to take that decision or to note or the decision of how if your response time of the functionality that you are doing needs to be optimized or improved, is that you have to be some measurement, right, of this response time to compare if there is it could have how many users it will be affected for this response time, right? So the measure that maybe you can think that maybe you can use the arithmetic mean, that is the average request. That is you have a window of number of the requests and a time, right? And you will sum all the response time of this request, and finally it will divide it by the number of the requests. So that result it will be the average request. But there are disadvantage, and there is not a good measurement to take a decision, because this result average request it will take the outliers of response time uh, in the average time. Because if you want to take a note, okay, is the regular response time that my user it will be faced in my application, it's not necessary to be the average time, because the average time is include the outliers, and the outliers time it could be affected for multiple reasons, and actually it's not something common, right? So your average request or time it will be a mess, or it will be a mess. So it's better to that there are better measurement to use it for the response time, right? Actually, the arithmetic mean is very useful if you are working with throughput, because the throughput is it's important to know if there is a delay, because with the delay you have to know that okay, how many requests per second affect the the response time. Okay, but maybe we can discuss later about the throughput, right? Okay, but okay, when we are talking about the throughput, maybe we can talking about the little slow that is when you extracting the concurrency. But okay, again, we can talking about later about the throughput. Okay, but there is a better measurement that you can use to decide it if you're what is the response time of your functionality, and that is the percentiles. The percentiles it could be included by the median that is the 50% of response time, right? Or the daily latency. Okay, here I have a small example to clarify these percentiles. Okay, so take a note that in this example we have a multiple response time in this window. Okay, we have that 2 second, 3, 4, 4, 4, 5, 8, 8, 15, and 30, right? Okay, if you want to extract, for example, the arithmetic mean, that is not a correct measurement, right? The regular response time for this request, it will be 7 seconds, right? But actually, if I ask you um, usually the 50% of your users it will receive it will expect that 7 second. Actually, no, because the 50% of your usage it will expect 4 seconds. Why? Because actually I sorted this window of response time, right? Ascendant, right? So if you take the middle of this sequence, it will be 4. So you will expect that the 50% of the response time, it will be less than 4 seconds. And the another 50%, it will be greater or equal of this 4. So for that reason, the median of the 50%, it will be a better measurement to take a decision if your functionality have to be improved. Okay, but there are more percentile that if you use it for multiple companies to have a better um, experience for the user. Taking a note that, for example, usually, the new user expected to have a better response time because there is not a lot of data in his storage for their users, right? So for the user that is regular um, for your customer or user that use regularly your application actually expected to have more data stored in your database. So that's mean that obviously the response time it will be worse than the new user. So and that's for you, it could be better to take note that the percentile 95, maybe it will be better because that is in that 95 words, a response time is your main customer. So for that, maybe you prefer to use the 55 percentage measurement, right? And well, that isn't a business decision, but you have to take a note that that could be useful for you to take a decision if your functionality have to be optimized. But take a note that if you taking more outliers, right, of this response time, it could be expensive and it will be uh, more difficult to be improved, right? Because actually, there will be more edge cases, and depend of you if you have to take a trade-off if you prefer to spend more time because there will be a revenue of this improvement, right? So take a note of that. And well, there is a service level objective. If you want to decided to actually the business decided to use the 99 percentage of if improvement, right? Or if there is an agreement because there are economic um, implications if you don't support a response time for the 99 percentage of your response time, right? So that is a business decision, and that's it, right? Okay, so that is all talking about of the response time. Okay, that the next topic is the throughput. The throughput actually is the is easier. It's the request per second. Um, Take a note that it's important to always trying to strike the throughput because the throughput it will be affect actually the response time, right? Because the throughput is actually the measurement that it will be affected, or it will be depend of the infrastructure that you have in your core of your business. Because actually the response time, there are multiple components that not only actually the implication if the infrastructure, I mean, in the power or the number of the or the size of the RAM, right? In this case, on the throughput, is that how many requests support the number of the cores that you have in your CPU, right? So that is actually determines for your hardwares, right? And actually, if you extract what is the throughput that you could have a better response time, that will know what will be the hardware needs for you. And maybe you have to take note that, okay, if you have a snapshot or a window of the response time that have a good performance, and there are another window that the response time is affected and is worse, you have to compare how many how many how is the throughput, and the throughput that your current infrastructure is uh, is supported with good performance, right? So that is important to know, that the number of requests that you support to have a good response time, right? And obviously, it's important to know to doing a scalability, right? That's it. And that is in summary about the throughput, right? Um, we have to talking about then what happened with the system overload, because it will be affected. And the consequence, there are multiples, okay? That the first thing that maybe we want to talk about is the queuing delay increase, okay? If you take a note that what is the a component that there is in a response time and an explanation of the queuing, right, delay, because when the number of the cores or the threads is limited, right, and the request that it will be processed in parallel or in concurrency, right, is limited, the new request that it will be received, it will be stored in this queuing delay, right? And depending of the number of the request that is stored in this queuing delay or queuing queuing, right, uh, finally it will be generate a worse response time, because that request that is living there have to wait multiple service process, have to wait, and finally it will affect and the experience of the user, right? So we have to take a note that um, if you increment the request per second, maybe you need to improve your core your infrastructure to support or to improve the response time. Not all the response time it will affect it for that throughput. Actually, obviously, it will be a problem maybe of the service process or the processing time, right? But you have to take a note first if it is it's a problem of the throughput, or actually it's a problem um, of the process of time, right? That's it. Um, what happened with that maze table failure? Because actually, when we are talking about there is a system overloaded, the experience of the user actually it will be a storm. Actually, it will generate a multiple problems, because there is only a single because there is a multiple user that have a bad experience, right? The consequence of have multiple users that have the words response time is because there will be increment the number of requests. Imagine that you are trying to click on a button and you expect that a consequence of that, right? But when you click something there, there is an unloading that is not, you feel like it's stuck. And when you think that it's stuck, you try to do something that maybe is common for everybody, is trying to click again, or reload the page, because you are thinking that, okay, if you are reloading the page, it will be um, faster the next time, right? But the problem is that for each request that you're trying to do it will be increment the queuing delay, because the new request, it will be passed for this queuing. And actually, at the moment that maybe you are trying to do the uh, 11 retry, the first request that you are doing already is processed, but you don't see it because actually you are in the 11 request time, right? So that means this data spiral, right? There will be long queue or high latency, and the client, it will be receive this timeout because there is no problem, right? It will be a retry storm because you will try to request multiple times, and then it will be an artificial loading grace, like in the side of the server. It will seem that there are multiple requests, but actually no, it's because the customer have a bad experience, and only it's trying to do a single action, right? But multiple times because it's trying to reload. So that's it. That is the meaning of the metastable failure, right? Okay, so if we want talking about a mitigation of strategies that you can do it to avoid this problem, because it's possible to have this problem in the real in the real software solution, right? Is that maybe you can decide that if you wanted to do it in the client side or in the server side. If you are doing in the client side, maybe you can. When I said client side, I don't want to talking about the browser, because actually there are a solution that it will be for the server to server. So the client side will be another server, right? Take a note of that. So if there are multiple requests that is trying to uh, be processed in this overloaded system, right? Um, you will receive a timeout, because obviously it not be possible to the timeout is actually is created when there is a limit of time that had to be processed your request, and if it's not processed at that time in the client server, it will be closed, it will be stopped, right? So the next time maybe you can retry it, but that maybe is the main problem. So the exponential back off is like if there isn't a timeout, it will not allow you, or it will increment the time that finally the real request, it will send it. Because for the user, it will be, okay, I will retry it. But that retry is not will be a real retry, it will be actually take a time, because if you already received a timeout, it's because there is an overload. So in the client side, automatically it will try to not increment the queuing delay. So in the client side, it will be a randomized time to be retried, right? That is the solution that we exponential backup, right? Um, to be controlled in your side. The another solution is just using the circuit breakers. The circuit breaker patterns actually is a solution when you receive a failure of obviously overload or the timeout, and obviously in that moment you have to take a note that the server is overloaded and needs to be not it need to take time to be recovered, right? So at that moment, the client side, it will generate a fallback maybe endpoint, right, or fallback response, right, but with cache. It's like always it will be receiving or updating this cache with a new with a request that this client is using. But at the moment that there is an overloaded, it will use this cache to not call the real endpoint, to trying to release the queuing delay, and in a window of time, it will be call the real endpoint. But it's in obviously the circuit breaker is only it's a solution if you are not doing an updating. It's maybe when you are trying to get something right, and instead to uh, get the real item that you have in another server, you prefer to use a cache of this item, right? To not create this cooking delay. So another solution is when in the server side, that is in the part of in the overloaded system, right, that is receiving this traffic of requests, right, is using the load shedding. Load shedding actually is when proactively the server is notifying, right, that okay, I am overloaded. So trying to reject it actually. But take a note that there are in this case there are maybe you can explain with there are in the site of the browser, right? And the browser can know that if the server is overloaded. So the server it could notify of the browser to try to not generate this cooking delay, and that is the solution in this case is uh, leave the browsing decision to not generate more requests, right? So that means the server side. um, in the back pressures is when obviously the same thing. There isn't something proactively, but in this case, it will be a notification for the client to say that okay, not continue doing because there is a rate limit and you need to wait a time to try to do it again. So it's notified that okay, you have to wait, right? That is mean the back pressure. So okay, that is a strategy that when there is a system overloaded, and maybe we. Okay, the next thing is talking about the implementation challenge. Okay, because when you are trying to do a solution of software solution, you are trying to take a note the performance metrics, performance implication that you can face it when you are trying to do a solution, and there is a network communication or transmission of multiple records, right? So in this case, we can be talking about the tailor lattice amplifications and the head of line of blocking, and it's very easy to understand. Okay, so um, when you are working with a monolithic or we're working with a single server that is doing everything, there will be affected by the tail latency, obviously, but maybe it will be the 1% of your request because we are talking about the tail latency is the 99 or 95 or 99 percentage of the worst response time. Okay, that means that it could be the one percentage of the response time it will be worse. So in that case, when there isn't a single thread of your process, that 1% of this process it will be affected, right? But what happens if you are working with distributed data system, right? When there are parallel jobs for a single thread, it's like that means if you have a request that is doing something in parallel in multiple jobs, imagine that you are doing uploading a video in YouTube, and YouTube it will split a video in multiple chunks. If for each chunk it will be processed in a job, right? So the problem is the tail latency is because if we are talking about that the 99 or 95 percentage of the response time, it will affect it with the worst outliers. That means that there will be a job of this parallel that will be affected. So that that job it will be generate this problem of head of line blocking because you cannot respond that all the chunks is completed, right, or processed because there isn't a single thread of these parallel jobs that is not completed. So that is the head of line blocking, because there is some thread that is blocking everything, even if there is multiple, if the rest of the jobs is have a good response time, right? But take a note that the head of the line of blocking also it will be affected if you of the number of the cores of thread that you have, and obviously if there is if there is an functionality of the user that is multiple requests, right? Imagine that to complete in a payment processes, right? And there are multiple steps, right? For the user, obviously, it's not completed if it's not completed the behavior or the feature if not completed all the steps. But if there isn't a single step that is stopped because that that the number of cores is cannot take in this process, obviously it will be a problem of performance, right? So you have to take a note that of heading of line of blocking and the tail latency application that it will affect when you are working with a distributed system or distributed or parallelisms, right? Requests. So that's it. Okay, the histogram aggregation isn't a problem when we're working with microservice system. Okay, take a note that if there isn't a request of the user that need to be thrown for multiple microservice, right? So in each microservice, there will be multiple 50 percentile response time, right? How do you know what will be 50 percentile measurement of the response time of a single request of this user? You have to take a note that this one, it will be if you take finally the response time of all of taking a note of all the microservice that is affected, and not have to see it like a single microservice uh, 50 percentile response time measurement, right? So that is the problem, because you have to always take in the response time, but not thinking like an isolated microservice. In other else, have to take in like an user experience response time. So that involves multiple microservices. So that is the idea that have to resolve in this performance measurement, right? So that's it. And there are multiple ways to get this 50% percentage, right? Measurement. As for example, if you are trying to the way maybe it's like every minute you will calculate in a window of, for example, 10 minutes. In 10 minutes, you will assume all the requests, you take a note all the requests in this window, and you will try to get a median measurement every minute. So that maybe you can generate for you a notification or alert if the throughput is affected in some measurement, right, of the response time. And well, there are open source solutions to implement this measurement of response time, and I read some of them. Open histogram on HTR histogram or TDGuest, right? So the decision is to you. Take a note of that. Take the trade-off decision, right? And always see the implication of the performance metrics when you are doing a functionality, right? Okay, that is everything for now. Thank you for watching this video again, and see you in the next video. Goodbye.